Today we have to discuss about matrix and a determinant. Chapter 4, Unit 2. Before go to matrix and determinant, we have to know about the linear equation. What is linear equation? What is system of linear equation? And how can you solve the linear equation? And you know before 9th class and 10th class, you know what is linear equation, what is a linear expression, what is a polynomial. You have to know. Everything you have to know. But we have to discuss. First, note 1, the system of linear equation. What is system of linear equation? Now there are two variables. Suppose we have to take it two variables and two unknowns, and that is called the system of linear equation. One equation, one unknown. Two equation, two unknown. Three equation, three unknown, and that is called the system of linear equation. It can be written in a matrix format, that is Ax equals to C. A equals to how much? Now the coefficient of x and y can be arranged in this way. That is a rectangular array form. A11, A12, A21, A22 from this way. And x is equal to what is that? Now x and y. And C is what is that? Now C1 and C2. A equals to 2 by 2 matrix. X is equal to 2 by 1 matrix. And C is equal to 2 by 1 matrix. That means the number of rows equals to 2 in A. Number of columns in A equals to 2. Then it is 2 by 2. And it can be read as a 2 by 2, but write as 2 into 2. Similar way, x is equal to 2 by 1 and c is equal to 2 by 1. The system of linear equation can be solved by many ways. And some ways are substitution method, elimination method, cross multiplication method, matrix inversion or matrix method, Cramer's rule, and determinant method. These are the methods, but we have to discuss about the matrix method and the Cramer's rule, because the substitution and elimination and cross multiplication already read in 9th and 10th level and plus 2 first year level. So now there are two systems. The one is the consistent equation system, another one is inconsistent system. If the solution of a linear equation exists, then the system of linear equation is said to be consistent. If the solution of linear equation does not exist, then system of linear equation is said to be inconsistent. Solution means maybe finite or infinite. Next one, matrix of order m by n. A matrix has m rows and n columns. We say a matrix of order m by n. That is, if A equals to, this way you have to write A11, A12, A1n, A21, A22, A2n, AM1, AM2 up to AMN, that means m by n. The number of rows is equal to m and number of m and number of columns is equal to n. If A is a m by n matrix with elements A11, A12, A1n in first row, A21, A22 up to A2n in second row, and so on. AM1, AM2 up to AMN in mth row. Similarly, you have to say that A11, A21 up to AM1 is first column, and so on. Again, we have to say A equals to Aij m by n in shortcut form, and that is a symbolically form, and that I is equal to 1 to m and j is equal to 1 to n. If m not equals to n, then matrix A is equal to rectangular matrix. If m is equal to n, then A is equal to square matrix. When the number of rows and the number of columns are equal, then matrix A is equal to square matrix. Transpose of a matrix. If A is equal to m by n matrix, then the transpose of A is A designated as a t or a dash equals to n by n. If the A equals to number of rows m and n, the transpose of A number of rows is equal to n and number of columns is equal to m. Equality of matrices. If A is equal to Aij, B equals to Bij. both orders are same and their corresponding entries are equal, that the two conditions are satisfied, then Aij is equal to Bij. The corresponding element to corresponding element are equal. Zero matrix or null matrix. If a matrix, each entry of which is 0, then matrix is called zero matrix. Example, 0 in matrix form 1 by 1. There are number of rows and number of columns are equal. 0, 0, 1 by 2. 0, 0, 0, 0, 2 by 2, and so on. Matrix A is minus A equals to minus Aij m by n. If A is equal to 1, 2, 3, 4, minus A equals to minus 1, minus 2, minus 3, minus 4. Multiplication of a matrix by a scalar. If A is equal to Aij m by n, then K is multiplied by A, then automatically K Aij m by n. K is a scalar. If A is equal to 1, 2, 3, 4, suppose question asks half into A, then half into that matrix, and automatically half into the multiply by each entries in that matrix. And so automatically the answer is half 1, 3 by 2, and 2. Again, we have to know in note 2, determinant of a square matrix A. That chapter is matrix and determinant. That means we have to know first the fundamentals, matrix and determinant both at a time. That's why first one we have to know about the matrix. Then some idea about the matrix. After all, we have to go for the determinant of a square matrix A. For 2 by 2 matrix, if A is equal to that 2 by 2 matrix, then determinant of A is, this symbol can be written mod A, dta, del, and this answer. And that mod symbol is here, and multiply first the diagonal elements you have to multiply, A11, A12, minus and non-diagonal entries multiplied A12, A21. That is the formula of the determinant of A. Similarly for 3 by 3 matrix. Suppose this is a 3 by 3, the order is 3. And that order A is equal to 3. And that order equals to 2. Because the square matrix, the order can be written as 2 only. The order can be written as only 3 only. So determinant A, first one A11, and the next just you have to eliminate it this way, and automatically those elements are, this can be taken as A22, A23, A32, A33 minus the exactly similar way A12 can be taken just as a perpendicular, and those elements are taken as A21, A23, A31, 33. Next one is plus A13, A12, A22, A31, A32. Similar way you have to write, and very simple way we have to find out the, if you take as this way, suppose A is equal to this 3 by 3, order is equal to 3, then determinant also can be taken as in column way. A11 first, A11, that means A22, A23, A32, A33. And next one is element minus A21. Before that we have to take, we take it A12, but here it minus A21. So automatically A21 is crossed, and then left places are A12, A13, A32, A33, and plus again A31 and A12, A13, A22, A23. Determinant. There are 7 properties are there. Property 1, the value of the determinant remains unchanged if its rows and columns are interchanged. If the row and column are interchanged, the answer is same. A is equal to A1. When rows or columns of a determinant are interchanged, then sign of a determinant changes. That means A is equal to, suppose this, suppose we take the 2 rows are interchanged, 1, 2, 3, and another one 7, 8, 9, and then one is 5, 4, 5, 6. Also automatically negative sign will be taken. Suppose the answer is, suppose x, then the answer is here minus x. So similar way, another, suppose we take it the column interchange, the 2 column interchange. So 1, 2, 3 can be written as 1, 7, 4 and 3, 9, 6 2, 8, 5. Again put negative we multiplied and so on. That's why it's a very important properties, very simple properties. Just two columns or two rows are interchanged, just negative kind will be taken. If any two rows or columns of a determinant are identical, then value of the determinant is 0. Suppose two example, two rows are identical, then the answer is 0. Three rows are identical, the answer is 0. Element of a row or column of a determinant is multiplied by a constant k, then its value gets multiplied by k. 1, 2, 3, 2, 4, 6, 4, 5, 6, and 2 can be just common. 1, 2, 3, 1, 2, 3, 4, 5, 6. The 2, 4, 6, the 2 is common. The answer is 2 into 0 because the two rows are identical, the answer is 0. Similarly, you have to take it. First row, A1 plus B1, A2 plus B2, A3 plus B3. And similar way, B1, B2, B3 and so on. How can you simplify? Very simple way, A1, A2, A3 and another one B1, B2, B3. And the other two rows are same. So automatically A1, A2, A3 and here A1, A2, A3. The answer is 0. B1, B2, B3, B1, B2, B3. The answer is 0. So total answer is 0. There is no requirement for the determinant simplification. And very simple way you have to the properties. By using the properties, the answer is 0. That means if some or all elements of a row or column of a determinant are expressed as a sum of two or more terms, then determinant can be expressed as the sum of two or more determinants. Similar way, property 6. A1 plus lambda C1, A2 plus lambda C2, A3 plus lambda C2. Lambda is a constant, suppose. So exactly that the two determinant and the lambda is common. So the two rows are suppose equal, they are identical, then the answer is 0. But here there is no columns or rows are identical, the answer is same, and you have to simplify. Very simple way you have to find out. 7. Very, very important. If all the elements on one side of the principal diagonal are zeros, then the value of the determinant is equal to the product of the elements in the principal diagonal. Example, suppose this is the diagonal 1 for 6, just one side. 1 for 6 side is 0, 0, 0. Then the answer is exactly 1 into 4 into 6 equal to 24. Suppose you have to take it just right side, just upper side is 0, 0, 0. The answer is exactly same, 1 into 4 into 6 equals to 24. The very important that properties. Next one you have to know about what is Saros diagram. Why Saros diagram can be used? Because of any triangle, suppose any triangle, there are 3 vertices in geometry of R square. There are, suppose A equals to x1, y1 and B is equal to x2, y2 and C is equal to x3, y3. Then what is the area? Now, exactly that is you have to find out the area this way. x1, y1, s2, y2, s3, y3 and 1, 1, 1 can be taken. So automatically that is, we have to write and this way. You have to know, find out the determinant. That formula can be not be taken. Just a Saros diagram can be taken and x1, y2, x2, y3, s3, y1, add it and next x2, y1, x3, y2, x1, y3 can be added and this the two terms can be subtracted. The answer is this way. This way you have to find out the determinant and that is the area of a triangle. Area, just you have to know about the area of a triangle. Just you know that the suppose 3 sides. You have to find out the first is the semi-perimeter. Semi-perimeter means S. S is already that. A plus B plus C by 2. That means A means AC. B means BC. B means AC and A means BC and C means AB line segment. That means the semi-perimeter is equal to this because it is a geometrically you have to suppose find out, suppose mensuration says, what is that? Now, so you have to find out S, A plus B plus C by 2. It is a scalene triangle. Scalene triangle means The area is equal to S into S minus I into S minus B into S minus B, C the whole root over. We have to find out the SC. That means x1 minus s3 whole square plus y1 minus y2. Arrows diagram is a very easy method to find out the area. 3-dimensional. So how can you find out the determinant? Very simple. Very simple. Suppose A L 1, 1, 2, B L 3, 2, 1, C L 1, 2, 3. What is that? Now just you have to take it 1, 1, 2, 3, 2, 1, 1, 2, 3. And again repeated 1, 1, 2, 3, 2, 1. That means you have to find out first just this way. 1, 2, 3. You have to multiply. Answer is 6. 3, 2, 2, 12. 1, 1, 1 plus 1. So answer is this. Minus 4 plus 2 plus 9. Exactly this way. 2, 2, 1. 1, 2, 1. 3, 1, 3. 2, 2, 1 means 4. 1, 2, 1 means 2. 3, 1, 3 means 9. We have to simplify and the answer is 4. Next one, note 3. Minor, cofactor, adjoint of a matrix or determinant. Minor of a matrix is minor of a determinant same. Cofactor of a matrix and cofactor of a determinant the same. And adjoint of a matrix and adjoint of a determinant the same theory, same answer. If a matrix 2 by 2 for 2 by 2 or the determinant exact say 2 by 2, minor for that matrix and minor for that determinant are same. How can you find out the minor? First A11 means opposite is A22, that is M11. A12 opposite is A21. A21 opposite means A12. A2 cofactor of that element. Cofactor of A11 means minus 1 whole square. Means the suffix is 1, 1. We have to add it. 1 plus 1 is 2. A12 means 1 plus 2 is equal to 3. 2, 1 means 2 plus 1 is equal to 3. 2, 2 means 2, 2 plus is equal to 4. So minus 1 whole square M11, that is C11. Minus 1 whole cube M12. Minus 1 whole cube M21. Minus 1 whole 4 M2. That means that if adding is even, that is a same as minor. Same sign. Minor and cofactor same sign. But addition is, if suffix is odd, also minor is positive, then cofactor is negative. If minor is negative, cofactor is positive. And so on. So C is equal to, what is that? C11, C12, C21, C22. How can you find out the adjoint of a matrix or determinant? The adjoint symbol is ADJA. So automatically the row can be changed C11, C12. Row can be changed to column C21, C2. So interchangeable row or column of C and vice versa. A is a square matrix. The inverse of A equals to A inverse the symbol. Adjoint A by determinant A must determinant A not equals to 0. Some theorems. There are some theorems. If A is equal to n by n square matrix, then A into adjoint A equals to adjoint A into A equals to AI. And say easy proofs, and you have to see the notes first, then you have to see the video. If A is equal to n by n and B is equal to n by n, same order, then A B and B A are of the same order. So where determinant A not equal to 0 and determinant B not equal to 0, because A B and B A are same order. If A is equal to n by n, determinant A equals to 0, then A is equal to singular matrix. If A is equal to n by n, determinant A not equal to 0, A is equal to non-singular matrix. Again theorem 3. A B determinant A into determinant B. And but A and B the same order, same square matrix. And A is equal to n by n is invertible if and only A is a non-singular matrix. The invertible means the determinant A not equals to 0. Is a matrix equation. So that means determinant A not equals to 0, there exists a unique solution. We have to find out the unique solution. Determinant A equals to 0, there exists a no solution. Determinant A equals to 0, adjoint A into C equals to suppose 0. There are two conditions, and then system may or may not be consistent. How can you solve the system of a linear equation? Our most important is solve the equation by matrix method. Another one is Kramer's rule. A very, very important for the examination. Annual examination is most important for that video. You have to see the video first. Ax is equal to C, x is equal to A inverse C. So x is equal to adjoint A by determinant A into C. That is the formula to solve the matrix method. Solve by Kramer's rule. Suppose the two unknowns, that are two equations. So step 1, Ax equal to C, A equals to this, we know x is equal to this xy, C is equal to C1, C2, and that is step 1. Find out the Axc. Determinant is not equal to 0, suppose. Then go for the step 3. Find del 1. How can you find out the del 1? The del 1 means also be del x can be written. Del y 2 means del y can be written. So del 1, what is that? Now the first column, just omit the first column and take it just C1, C2, and A1, 2 and A2, 2 can be taken, and that is del 1. Similar way, the second column can be omit, also A11, A12, C1, C2. So x is equal to step 4, del 1 by del and y is equal to del 2. To del not equal to 0, system has unique solution. Del is equal to 0, del 1 not equal to 0, del 2 no, suppose not equal to 0. The system has no solution, no unique solution, not independent. The same answer. So question must be, one mark question must be given by the CHSE board. Must be. So del, suppose the determinant equals to 0. That means A11 by A21 equals to A12 by A22. Suppose del is equal to 0, del x is equal to 0, del y equals to 0. That is A11 by A21, A12 by A22, C1 by C2. There are infinite number of solutions. Remember that formula. Geometrically, suppose we say the two lines are coincident. That this is L1 and this is L2. Matrices. Matrix addition. A is the same and B is the same. Same A and B are the same order. A plus B can be C as A. A minus B also same. This way you have to find out 1, 2, 3, 4, 6, 7, 8, 9. And just entry to entry, just add it. Entry to entry, just add it. Scalar multiplication, alpha into A, alpha Aij, alpha ij scalar, then that means alpha Aij whole, that is m by n. Same order, and that is this. And suppose the 4 can be multiplied 1, 2, 4, 5. The answer directly 4 can be multiplied directly to multiplication in the matrix. But determinant is here not. This way. Multiplication of matrices. A is equal to Aij, B is equal to Bjk. Just a number of column in A and number of rows in B are same. Must be this is N and this is N. Also answer AB can be written as Cik. Aij, Bjk. So Cik. And the order is M by B. M and B. Also M by B. Multiplication of N by N. So Aii called elements of leading diagonal element. Aii called the leading diagonal element. That is a unit matrix. A is the elements of a leading diagonal. What is that leading diagonal? Well, suppose the for 1 by 1, so A equals to only 1. For 2 by 2, that means A equals to 1, 0, 0, 1, and so on. And that is next one, diagonal matrix. All diagonal elements are not 0. So A is equal to called the diagonal matrix. All diagonal elements are not. Sorry. The algebra of matrices. Commutative, associative, identity, inverse. Inverse means A plus minus A equals to 0, minus A plus A. Then that means minus A is called additive inverse of A and vice versa. A plus 0 is equal to A, 0 plus A. That means 0 is called additive identity matrix. Commutative, AB not equals to BA. Associative, AB into C equal to ABC. AI is equal to II is equal to A. Also A is the multiplicative identity. Identity means I is equal to, suppose 2 by 2 matrix, the answer is 1, 0, 0, 1. This is the identity matrix. A into 1 by A, I. 1 by A into A. Also 1 by A means A inverse, A minus 1. This is called multiplicative inverse of a matrix and vice versa. That means 1 by A inverse is A. A is inverse 1 by A. Over multiplication. A plus B into C, C plus B. That first one is addition, next one is multiplication. Multiplication over addition. First one is multiplication, second one is addition. The most note is there. See the notes first and video must be see to the video, and next one is the examples and exercise from elements of mathematics, and the next one is the R.D. Sharma book necessary, and see the matrix operation and solutions etc. for MATLAB programming book and authored by me, Dr. Ajay Kumar Singh, which is published by Kalyani Publisher. It's very important, but MATLAB programming, how can you find out the matrix theory? That is, a MATLAB means matrix laboratory. The matrix way, you have to find out the addition, subtraction, multiplication, and so on, adjoint, cofactors, and etc. How can you show that this is there? Suppose MATLAB programming, we have to first find out the creating matrices. That way you have to create 16, 3, 5, 10. That means automatically just run the key, and that is enter the key. The answer is 16, 3, 5, 10. And this is the very simple syntax. You have to take it. Just suppose A is equal to this. The answer is this. Suppose you take it A dot star 2. That means automatically 2 can be multiplied. Suppose A star 2. So automatically this way you have to find out. Matrix with matrix multiplication. Suppose there are 3 by 3 and here is 3 by 3. And so A dot star B, automatically the result will find out by MATLAB programming. Very simple way you have to find out. We already designed the matrix operation, matrix addition, matrix multiplication, inverse of a matrix, matrix subtraction, transpose of a matrix, adjoint of a matrix. How can you find out the inverse of a matrix, adjoint of a matrix? Lastly, my dear students, and this is important for my topic, that is matrix and determinant, and this is the interesting topic and very important topic, and one question must be from CHSC board, and other questions are very important, and questions are most important. You have to remember first, how can you show the first notes, then video programs, next you have to do the all examples and exercises from Elements of Mathematics and R.D. Sharma book, the very important book. That's why it is the lastly I have to say it is useful for yourself, and best of luck. God bless you. Thank you very much.